China's got better technology in some sense, or better people, or is more innovative than America. Maybe they sort of see what effect it has on the economy. In a very dangerous situation at the moment, because the economy, by a lot of people's measure, is sort of overheated. But it was all for a very specific reason, right? It was because of a particular product, which is very popular, very profitable, which are these AI models. But it's a product for which, almost uniquely, you cannot block the import of, and you cannot put tariffs on. If you make this thing available for free, and again, because it's all about algorithmic methods, it's zero marginal cost. You can produce as many of these things as you want. Once you've got one of them, you can just copy them. You can deploy this better method to all your GPUs, and you flood the market with something which is unblockable and unstoppable. And that's the thing that the economy is depending upon at the moment for its elevated valuation.
All right, John, thank you so much for coming on the pod. I just wanted to start out with an introduction and a bit about your background, and then we'll kick it over to the innovation game.
Sure. Yeah. So my name is John Fletcher. I'm the inventor of the innovation game, which is a protocol which has been up and running for a year or so now. We've only really been sort of actively bringing people in very actively for about, I'd say about 7 months. So we really are quite early days. My background's in physics and mathematics. So I've got a PhD in sort of maths and theoretical physics. I was here at Cambridge University. And it's really was my experience in computational physics specifically, which kind of inspired the idea of the innovation game, coupled with the fact that I'd found out about Bitcoin. This was around sort of 2011, 2012. And I was sort of thinking how to, maybe I could sort of leverage crypto economics to make my research in sort of computational physics go a bit faster. So that was really kind of the origin of it, as a combination of economics and sort of mathematics and algorithms and computers, which are really my kind of great passions in life. So I was amazed to hear about Bitcoin, which sort of did seem to combine those things. And it's been quite a long process, figuring out all of the details. It's quite an elaborate idea, as you know, and a very ambitious one. But yeah, we've picked up a lot of great people on the way, and now it's really live and out there in the world.
Yeah, I would definitely agree. It's an ambitious idea. It's one of the first of its kind. Before we dive into some of the higher level topics I want to get to, can you just first explain what the innovation game is and then how some of the mechanics of the protocol works?
Sure. Yeah. I mean, at the highest level, the innovation game is a protocol for incentivizing the development of more performant algorithms. So these algorithms are things that are really kind of useful, primarily in science and technology and AI. This is our focus, and it's really kind of algorithms for science and algorithms for AI and all the most important applications of computers really in the modern world. And we chose to focus on algorithms because, I mean, one of the big kind of revelations, I would say, I had was that it's quite important when you want to compute the answer to something. That's great, but it's very different sort of that you run a computer to get some sort of a numerical answer to some question out. It's quite different from trying to find a better algorithm. It's just one higher level of abstraction. So that means it's almost like that thing, the difference between teaching a man to fish and giving him a fish. It's a better sort of method which can then be sort of improved and worked upon by others. And, if you look into the history of it, a lot of the kind of greatest breakthroughs, in technology and history have come specifically from algorithmic breakthroughs. So not, faster hardware, not more data, specifically from that. And yet, this very fact is underappreciated for some interesting reasons. And so, there's no protocol or even centralized company, as far as we know, that focuses on, developing more performant algorithms specifically, for some very interesting economic reasons. So another thing which makes, I guess, the innovation game sort of rather unique is, a lot of protocols, if they're the kind of utility type, maybe not meme coins, but the sort of utility protocol, it's often you say it's a sort of decentralized version of X, where X is something which already exists in the world, is often already known to be really important and probably kind of, already running pretty well in a centralized fashion. But with the innovation game, it's not a decentralized version of X. There is no such, this is the first in a centralized or centralized context time that this has been attempted. And we believe it, in fact, the reason is because it's something which is only possible in the decentralized context. It simply doesn't make sense and is impossible to do it any other way. So that's another kind of interesting feature I would encourage people to look into.
Yeah. So how do the mechanics break down if you're using the protocol? I know that there are multiple parties involved, creates a market for algorithms. So just for someone that's never heard of this before, how would you explain it?
Yeah, so I think if you do have some, at least kind of very basic knowledge of Bitcoin, that's probably the easiest way in. I could try and re-explain it for people who know nothing about. I mean, I just sum up how Bitcoin works. I mean, people perform sort of proof of work. In that case, they're performing these sort of hash calculations, which are they're almost sort of random numbers which are being generated by a hash, which is, you can think of it a bit like a random number generator, and it's sort of an enormous amount of computation. And really, the purpose that it serves in Bitcoin primarily is to provide security for the protocol, because in order to sort of undermine Bitcoin or send some Bitcoins a place where they shouldn't be going, you'd really have to have so much more compute than everybody else in the network put together, which is a very, very difficult thing to do, because there are thousands of people all the way around the world finding very cheap sources of energy to mine Bitcoin at huge industrial scales. So that was the sort of purpose of it in Bitcoin, to provide security. But if you think about it, Bitcoin also had other effects. Maybe they weren't intended, maybe they were just sort of side effects. One of them is that they created a huge market for ASIC miners. And now there are factories all the way around the world sort of, manufacturing ASIC miners, which is something, literally just to do hashes as quickly as possible, which is something that certainly those factories would not have been created if it weren't for Bitcoin. Their sole market is Bitcoin, and, they're very profitable, and people do a lot of R&D to develop more efficient ASIC miners. So the very kind of basics of the idea was, so if, Satoshi could, in a sense, choose to create a protocol which had that effect, then maybe you can create a protocol which has sort of, other related effects, that people go out and try and find more, performant algorithms to perform certain calculations. Not necessarily because they're interested in the calculations themselves, or they may not even be interested in the algorithm. It's sort of the same motivation as for Bitcoin. They just want to make money, right? They know that if you do this, you'll be able to mine more efficiently, and you'll be able to make money. So it sort of causes amazing things to happen, on a very kind of large industrial scale. And with algorithm development, I mean, it wasn't too much of a leap to think, okay, in Bitcoin, it just so happens that the only way really to mine more efficiently is to find cheaper electricity or find a kind of better piece of hardware. In the innovation game, you can mine more efficiently by having cheaper electricity, better hardware, but also a more performant algorithm. So it just gives you that little bit of extra scope, for optimization. And then all of the wonderful economic forces around the world now push people to find better hardware, find better electricity, but also develop more performant algorithms, which, at least in the innovation game, they are compelled to share with the rest of the world. And of course, these algorithms are, designed, the proof of work is designed such that these algorithms can also be taken and used on real calculations. So not just sort of random ones like they're doing for proof of work in the innovation game. The proof of work is specifically designed so that the algorithms are basically the same ones to do the real world task and to do the mining in the innovation game. And so that creates value, huge value in the fact that you have a more performant algorithm and an optimized implementation of that algorithm. And that is value that we capture, and we can talk about this in a bit, and sort of make it available for license. And that's our value capture mechanism. So we're not just putting things out, we're also accumulating this asset of great value. And that's where the demand for the token comes from, because in return for using that IP, you're required to buy a license, which is denominated in the TIG token.
Right. We're talking about algorithms, not just within AI, but within other fields too. So that's right. I remember when I was first looking into the project, I was really surprised by how many areas of scientific innovation algorithms touch. Probably shouldn't have been, but I was. So yep. Could you just talk about some of those different use cases? I mean, you guys are running a couple different challenges right now. Yeah, just in different fields, how this plays in and some of the problems you guys are trying to solve.
Yeah, sure. So you're right. They are incredibly fundamental, these algorithmic problems. There are many what's called, I think I heard Dennis Sasabas use this phrase, that they could root node problems. So they're problems which are so fundamental that if you do an improvement, say, in a method to solve this problem, it has all these other downstream effects to improve other things. And so, if you could solve anything, if you could make progress anyway, you'd want to make progress at these sort of very fundamental level, low level types of problems. And these are the ones which we select for the innovation game. There are a finite number of them in the world. I'd say, if you probably no more than the order of 1,000, maybe fewer than that. And they kind of sit right at the bottom of sort of maths, physics, science, and AI, and they just have effects which are kind of stupendously, impactful in the way that they change things. In AI, you get things like, backpropagation and, optimized non-convex optimization and so on. But these things are very famous among scientists. A few examples that we have in at the moment is, searching through vector databases, something called Boolean satisfiability, which has many applications. One is sort of designing more efficient layouts for microchips, so they're more efficient. We have a version of the so-called knapsack problem, which has many applications from gene cluster sequencing to, if you heard about this idea of kind of multi-constraint auctions that a guy won a Nobel Prize for recently, that they used to auction broadband spectra, which was a pretty big application, sort of worth billions of dollars. Then we have another one, which is capacitive vehicle routing. So it's really the classic example of that is sort of logistics. Like if you want to make many deliveries, you can save on time and energy by sort of routing people in the most efficient way, and getting them there within certain time slots as well is another constraint. So these are sort of very kind of famous, and actually they're very old problems. Like in a lot of cases, people were talking about these problems, some sort of way, maybe 100 years ago. So the problem itself is often sort of classic and very old, and the set of all of these very important root node problems is actually relatively stable. The kind of very fast advances and changes you get in this world are typically development of new methods and new strategies for solving these problems. So that's very, very dynamic, and people will disagree as to what the best strategy is, and people are working on one research direction or another. But what most people tend to agree on is the set of important problems. And that's kind of what for the innovation game, we sort of collect the problems and we just outsource and crowdsource the solutions, which in a sense is the hard bit. That's why we do that through crowdsourcing. So it is, if you Google kind of algorithms, say on YouTube, there's a video with I think it's like more than 10 million hits by a guy called Veritasium. I don't know if you've heard about this. It's called The Most Important Algorithm in the World. It's about the fast Fourier transform. Again, most people have never heard about this, but it's sort of, you had incredible, I would say that's an excellent introduction to algorithms for the kind of uninitiated, because it really is just a procedure, a computational procedure, which was so much more powerful than the previous generation. It kind of, credibly changed the course of history. So, that might be something that your viewers would like to look into. It was actually something to do about nuclear testing. They could test that the Russians weren't breaking the nuclear treaties against testing because of the fast Fourier transform, just to give you a bit of a heads up. But very, very fundamental stuff. And almost every area of technology is really powered by this. And in fact, there were some great kind of survey papers done showing that the effect of speeding up compute of algorithms is significantly greater than the effect of having better hardware over the years, which is, from Moore's law and stuff, that's a pretty high bar, right? Exponentially increasing. But the effect of algorithms has been significantly greater, and that advantage over hardware is going to increase in the future as well. So algorithms become more important as problem sizes get bigger, which is happening at the moment.
Right, and that makes so much sense. And I think that's one of the core things about TIG is hardware gets a lot of press, right? People are scaling hardware. It's a very predictable way to scale. Algorithms, not so much. And one of the challenges, it seems, is that the funding for algorithms is kind of a mess, or like there's not enough funding for algorithms in private markets, right? So like usually from the government or some sort of research institute. So I was wondering if you could touch on the history of that and just why that has been the case so far.
Yeah, this is a great question. And I, dug into that for obvious reasons, because I wanted to have a good, explanation, a sort of story for why what we're doing here is really important. I knew intuitively it was important, but again, I had the sort of the same questions as you. And what I found out was absolutely fascinating. So algorithms, historically, most of the research and big breakthroughs has been done through government-funded research. So maybe government institutions, maybe universities. A little bit sometimes it's been done by things that are nominally privately funded. But sometimes when you look into it a little bit more, like Bell Labs was, for example, funded by a private company, but it was a monopoly, and it was a sort of quid pro quo. Like, we'll fund what would normally be government-funded research for you. We'll take that off your hands if you don't break up our monopoly. So again, it was by proxy, it was government funding. And, some people think that sort of Google has a similar, albeit no doubt, unofficial arrangement with the American government. So you can see, but it's quite easy to see why this happens, because algorithmic research, the progress is extremely unpredictable. And investors don't like this. So you think any kind of investor with a large amount of money would much rather hear, oh, if I give you X billion dollars, you'll give me that money back plus 10%, in 2 years or 1 year. They don't like to hear, oh, maybe there's a 1 in 20 or 1 in 50 chance that you're going to get a 10x on this or a 50x. It's the nature of deploying large amounts of capital that often this is not the kind of investment which is favored by a private market. And you could put billions and billions into algorithm research and just get nothing for 20 years, decades. Often the algorithmic research is quite specific. If you improve hardware, you improve, albeit a bit by a lower magnitude, but you improve all calculations across the board. So this is a much nicer thing. They like to spread their risk. It's a sort of engineering problem. They kind of chip away at it, and history has shown that you can get these predictable returns. And this was the origin of Moore's law. So Moore's law kind of went like that, and everybody was amazed at how well it worked, for decades. If you look into the progress in algorithms, again, it's field specific, and it just goes zzz, boom, zzz, boom. And these flat bits are decades, and these booms are maybe 100x. Sometimes 1,000x increases, but you don't know who's going to come up with it. You don't know, when it's going to happen. And so typically and there aren't that many people who can credibly do it as well. These people are quite a scarce resource. They often, they're kind of more academically focused, and even paying them more money doesn't make them work harder. So there's kind of a bottleneck in human capital. So this is why historically companies were quite happy to leave this to government research. They knew, dependably, that these academics will often publish. They want the kind of notoriety of having made a big breakthrough. They'll publish openly, and so everybody will get the benefit of it. But in practice, whenever anything is published openly, in fact, the bigger guys get proportionally more benefit than everybody else. Like if someone has an algorithmic breakthrough, like Google is going to benefit more than me and you. Like in a sense, so again, the bigger guys, even disproportionately, were particularly keen on the government pumping kind of billions of dollars into fundamental research, much of which went into sort of algorithmic research. But the problem is that this sort of era is coming to a close. So one of the reasons, in fact, this was really quite shocking, that a lot of economists, in fact, didn't sort of discourage people to look for market mechanisms which could fund algorithmic research and other fundamental science as well. And one of the reasons is because these things, as I said, can be so powerful that if they're privately investable, what happens if a company gets this 1,000x increase and simply decides to keep it as a trade secret? So the economy is sort of like, okay, you can go in this direction because private funding tends to be more efficiently allocated, for example, than government funding. And they say, okay, that has benefits, but what we believe, and the zeitgeist was for many decades, that that will give you a benefit, but the potential downside is much larger. So don't even go there. Don't waste your time looking at that, because you're probably just going to make things worse. You'll increase the efficiency of allocation, but it might greatly increase the risk of a monopoly forming. And so this is again, as far as I can tell, a reason why people didn't really think about it very much. But we've come to a point now where it's people's hands are going to be forced, and the reason is because of this phenomenon of basically AIs developing algorithms themselves. It will start to become privately investable. And you might think, great, but that means that private companies will have these powerful things in their hands. And it's just, are they going to make them open or not? This is really what the innovation game is about, because they'll make them open if they believe the incentive is to make them open. Of course, they're going to benefit more than they're going to lose. It's always a trade-off. And if they're not, if they don't believe that, they'll typically keep it closed. And that will be very, very bad for the world. It'll be bad for innovation. Because if you get monopolies, innovation eventually stops, because you get someone so far out ahead, they've crushed the competition. So why try harder? It's simply irrational to invest more and more in R&D when nobody else has even got an R&D team, right? Because they all went bankrupt. So this is a kind of problem which is now, I think that people have been refraining from thinking about it for too long, but now it's sort of upon us. So this is what we're trying to deal with.
Kind of answers my next question of why keeping this stuff open source is so important. I know that's a very fundamental part of the innovation game. So are we seeing this? Are we seeing signs of this? I mean, obviously you have, private companies, open source companies, people who release open source models, but where are we starting to see this shift specifically? Are there specific instances we can point to?
Well, it is interesting with open source. Open source has always been, I think there's a kind of like a mix of ideology and just sort of kind of hard-nosed kind of economic calculus. I think in the very early days of open source, even before open source, there was something called free software. A lot of people thought it was just purely an ideological position. Like, if I'm going to run some program on my computer, I should be allowed to see what it's doing, like in detail. What is its source code? A lot of people agreed with that. There's very kind of strong arguments to support that point of view. What people didn't think was that it would start to become, in fact, sort of make economic sense. It's not some sort of communist, well, it might have stayed that way, some sort of ideological driven movement. Nowadays, some of the biggest and most capitalist companies in the world are some of the biggest contributors to open source, really just because it makes sense for them. Like Microsoft, for example, they get more out of it, they get more back than they put in. So that was a bit of an unexpected turn. That's really the reason why it sort of took off. Things like Linux are just the sort of best in its class in the world, and it sort of accelerates and gets better at such a rate that it'll almost certainly, would be extremely difficult to catch up with that. So with proprietary alternatives. But the problem is that not all software is like Linux or the successful open source projects. You can open source anything you like, but it doesn't mean to say it's going to be successful and it's going to reach this kind of, sort of escape velocity where so many people are sort of interested in contributing to your project that it becomes sort of better than proprietary alternatives. So this has really been where open source is, in a sense, stuck. Huge achievements in its domain, but I think few people appreciate it, how the domain of different types of software and kind of code for which open source works well is in fact very, very small subset of all code. And so this is why it's opened up this. It's almost like a completely different discussion, which has been brought up by AI. Is open source AI going to be a thing? And unfortunately, open source AI falls out of that category where it works well economically. And so people are pushing it more from the ideological perspective, which is as valid an argument as ever. They want to be able to see what's going on their computers. They want to know that it hasn't been trained maybe with some sort of biased data, pushing one agenda or another. But unfortunately, with the current open source model, it's simply economically irrational to make it open source. So this is the thing. It's not like Linux. People have to do that. It wasn't designed that way, but it's simply the sort of reality of the way that it's structured. And so open source is kind of, a lot of people are talking about it, again, mostly for ideological reasons. There have been some, the kind of people who release open models, and again, this is quite key. So open source in the context of AI, we have to be quite precise. It means releasing the data, releasing the methods by which it was trained and the model. So a lot of people say, if you release the model, you can see the weights. This is open source. In fact, it's not, because the definition of open source really is that you should be given the information, the sort of preferred form to make modifications. If you're just given a model and a load of weights, you can fine tune it a little bit. You can make a certain area a bit better, make another area a bit worse. But you can't really build on top of it in like a scientific point of view, because you don't know how it was built and you cannot back out the data and the methods from that model. So in fact, it doesn't accord to the principles of open source. And so this is the reason why the first new definition of open source in 25 years was released, I think about 2 months ago, where they specifically say this is what open source AI means. And it means you have to give the methods, you have to give the data, and you have to give the weights. So the ideological motivation and will to make this work is as strong as ever. The economics, unfortunately, don't make it as easy as it is for some other classes of software. And also there's a lot of confusion because some people say this is open source when it's not, because it's, open weights is not open source, unfortunately. Even, in fact, OpenAI recognized that. I don't know if you heard lately, they released their first ever open model, and they were very careful to say this isn't an open weights model. They didn't call it an open source model because it isn't, by the very well-defined open source definition, which you can find on the open source website. So, I think it is commendable that the companies such as Meta, for example, have released open weights models. You'd rather have an open weights model than no model at all. It has various advantages, like you could run it locally, so people like privacy, but it doesn't allow you to build on it in a scientific way. And so the first thing, I guess, which is really being kind of sorted out at the moment is the sort of an agreement to use the language consistently, consistent with definitions. And then the other big thing is, how do you make it economically rational? And so, what Meta is doing, for example, they're burning money like nobody would, can believe. Of course, all these GPUs and the cost of running them are subsidized by, I suppose, ad revenue from Instagram and their other things. But of course, that's not sustainable, right? Like at some point, they have to find a way to capture the value from the things that they're making. And open source advocates really do not like to rely on, people like Mark Zuckerberg, like for their only open source models, right? The whole point is they want to be able to do it themselves. They're kind of like hobbyists and stuff. At the moment, they're prohibited from doing that. So this is really what the big kind of decentralized AI movement is about, because the way that you make it, to cut a long story short, the way that you make it economically viable and self-sustaining is through crypto-related decentralized technology, because that allows for flows of value capture, which can be routed back to the people who contribute. So the innovation games are part of that. It's not all of that. We look at the algorithm side. There are other people, as you probably heard, focusing on the crowdsourcing compute, other people focusing on crowdsourcing data. So these are sort of big pillars of AI and things that you need to have an open source AI. But I should say, I have to be realistic, of all of those pillars, algorithms are by far the most important, by orders of magnitude. They're the most powerful thing. They're the least talked about for the reasons that we just went into. But if you don't have the best algorithm, it doesn't matter how many GPUs you can crowdsource or how much data you have. If you're 100 times less efficient, they're going to be less efficient anyway because they're decentralized. But they might still be able to kind of make up with just numbers. But without the best algorithm, there's no hope whatsoever. So you have to make sure those things are open and the state-of-the-art methods are available.
Is it something that's completely unpredictable? We really don't know when we're going to hit a better algorithm?
So historically, yes. In the future, very soon, no, I would say, or at least it's going to be a lot less unpredictable. And the reason is very interesting because AI itself, and they're making a huge amount of progress in this, can now be used to search for better algorithms on an industrial scale. So one of the reasons why it was so unpredictable, again, I said there's relatively few numbers of people in the world who can do algorithmic developments, always be done by humans. And you get a few kind of very, very smart people and, but the small number of them means that, the variance is very high. And also, it's only kind of hard that they work. It's not a scalable investment. You can pay all of them whatever an academic earns. I don't know, maybe sort of, $50,000 a year or something if they're lucky. Then after that, there's just nowhere else to put the money. So they put it in GPUs instead. They put it in hardware. They put it in data if they want to make better AIs. Right now, we're transitioning to a world where algorithm development is a scalable investment for the first time ever in history. If you buy more computers, you will double your probability of discovering a better algorithm in any given time window. And that it will be transformational. It will mean that you can put private investment into it. But as I said before, it's a double-edged sword. It's investable. You'll get more money into it. But the real kicker is that it's less likely, and under the current system of incentives, that these things will be published openly because it was so expensive to run all those GPUs for this algorithm search that you feel like you have to capture the value from it when you find something, right? You can't just give it to the world. And those that do may be outcompeted by those that don't, right? The other people start to get ahead of them. They can charge someone else to use their better algorithm over an API maybe and get all this money, and then they can buy more GPUs for the next search round, right? Mm-hmm. So it's an unstable equilibrium. It doesn't matter how good people's intentions are. It simply means because anyone can defect, and the whole thing will kind of collapse into centralization. And this is what economists warned about for decades, right? Don't even look there. Don't even try and make this kind of research available for private investment because it's so powerful. Some things are too powerful to be kept private, and algorithms are one of them.
Yeah, that makes a lot of sense. And that's interesting that we're transitioning back to a point where, compute was a very scalable, investable, predictable way of scaling. And now we're using compute and models to get to the part that is unpredictable and harder to scale. Are you seeing this from the supply side of innovators? Are you seeing people already scaling this way?
So as far as I know, none of the innovators are using machines to come up with the algorithms yet. They may be, and they just don't want to tell us, right? But crypto miners are notoriously secretive for quite good reasons, sort of competitive dynamics. But if they're not now, they will be very soon, essentially. So this sort of lifts the lid on the restriction. They're probably, in each one of our kind of challenges, maybe there's realistically in the high hundreds people in the world that could really meaningfully contribute to it. And probably more realistically, sort of even fewer than that who are likely to get a significant breakthrough. So this is great. I mean, of course, huge amounts have been achieved in algorithms sort of over the years, but it's not the kind of thing that you can just sort of build on and build on. As I said, you're always looking for a kind of an economic feedback loop. So they find better algorithms, they capture some value from that, but unless the value that they capture then increases their productivity, you don't have this loop where you can just build. And in the case where all the people working on algorithms who are really into it are already doing it, what happens if they have more money? I mean, maybe they can hire some more postdocs and PhD students and stuff like that. But history shows there's actually, no matter how many people you just get sort of lower quality people. So all the geniuses are often go there anyway, and then you just get people who are slightly less capable. So there is some capacity in that. We could get all the brilliant people who went into investment banking back into algorithms. That would be a nice thing. Right. But again, there is a limit to it. It will stop, and that's because it's the human bottleneck. To train up somebody to be able to come up with the state of the art algorithm, again, they have to probably train and be in that field for many years. But with sort of computers sort of unleashing this sort of new dimension, that all changes. And as they say, the old kind of hockey analogy, skate to where the puck's going, not where the puck is at the moment. Because we can see this coming, right? I mean, algorithm development is the next big inflection point, acceleration in technology, and we will kind of be there, up and running and ready when it starts to take off, which I think will be within the next year. We're going to start hearing a huge amount about it.
Cool. So within that conversation, we're talking about the total addressable market of people who have the skill set to be able to do this kind of work and actually really make breakthroughs. So until we get to the point that these really are all being scaled by machines, it seems like a challenge for TIG would be growing the supply side of innovators, because you can have tokens to help solve the cold start problem. That's one of the things that crypto is really good at. But if you only have that TAM of, I don't know how many people, it's not like Uber where the total number of drivers is huge. So I guess first, has this been a challenge for you guys? And if so, how are you approaching scaling the innovator side of the market?
Yeah, so it has been a challenge, but maybe not for quite the reason that you speculate. I mean, at least so far, problems, as you get bigger, the sort of nature of the challenges kind of changes, of course. The first challenge we have is getting people, the type of people who work on this, who are often work in a kind of academic content. Sometimes they work in industry, which actually, by the way, is also fine, because industry is very open-minded about being involved in open source projects, much more than what people think. So it's not like, you'll never be able to put an algorithm in an innovation game. It's effectively the same as open sourcing it, but you get the added benefit of a monetary reward as well. So it's just, it's strictly positive. But the types of sort of world-leading kind of really competitive people in this area is limited. The nature of their personalities tends to be that they often are not big crypto fans. This is what we found out, that they seem a bit skeptical about it. I guess they're kind of conservative, relatively serious people. If we're able to get 5 minutes speaking to them, they love it. They never want to leave, right? They think of all their Christmases have come at once. But there is a little bit of, especially the best people, they probably get lots of emails about things, and that our scheme sounds a little bit like crypto, so it works better through personal introductions. But we find that especially when you get a kind of credible person at the top, some of these people run competitions, international competitions for the best vehicle routing algorithm or the best SAT algorithm, to which all the competitive people sort of come, and they have a conference, and probably in the hundreds, maybe even thousands of people. So that these people have the connections, these people can communicate with one another. So the original barrier was sort of getting through that skepticism. After that, it seems to be working out that they can kind of spread it to their community. Again, it's sort of hierarchy. Some guy who's considered eminent in the field tells you that this thing is legit, and suddenly you've got a license to do the thing you were doing anyway, but yet a very substantial reward, especially from standards of these people who tend to work in, not often they don't get paid very much, unless they happen to be sort of working in AI or finance. But that's a very small subsection of all of technology. So in that case, it's going well so far, I would say. And we will reach the scaling limit, though, and the idea is to sort of dovetail into the automated algorithm development. But interestingly, if your viewers want to look into, say, like something called Fun Search, that Google DeepMind published a paper, I think it was about 18 months ago now. They found improvements from the state of the art in two very important problems. One's called the CAPSET problem. Another one's sort of type of fast matrices multiplication. And these were areas that plateaued for a very, very long time. Nobody had ever found them significant. And the computer found significant algorithmic optimization in each of these famous problems that are plateaued for a leg. So it's happening right now, essentially. And we're transitioning into that. All the big companies are working on it, OpenAI, Anthropic, and so on. If you dig in, you can see. I mean, they're not talking about it, right? But the thing is, they know that this is what happens. This is the thing that's really going to scale you, because you don't even have to buy new GPUs. You just deploy a better algorithm to the thousands or hundreds of thousands that you already own at zero marginal cost. And these schemes can be, incredibly impactful. I mean, the current AI revolution was sparked by the attention mechanism, which led for the transformer architecture, about a 100x improvement in efficiency. Again, transformational. That's the difference between ChatGPT 3.5 and whatever came before, whatever kind of nonsense generation machine came before. It's the difference. It's night and day. DeepSeek's thing was estimated to be about a 57x improvement. I mean, these are vast things. Like, when do you ever get a piece of hardware that's 57 times faster? I mean, the chips themselves improve, 10 or 20% a year if you're lucky. 57x in a single good idea had by, we assume, a human being. So this is a great area of interest, and the fact that it will become a scalable investment is the big news. Is the economics, essentially. It's not the fact that algorithms are incredibly powerful. It's not news, but the fact that you could do this in a scalable and investable way where you can attract private capital, that's the big news.
Yeah, that's really interesting. And as you guys scale, I mean, there are people from all over the world who maybe they're not that top down, really well known, and getting different people kind of down the tree, but maybe it's some brilliant kid in a different country who hears about this and all of a sudden has a great idea. And that's what's so great about it is it is the marginal cost of like coming up with these things is zero,
yes.
Right? Yeah, I mean, it's
well, if you think that's a fantastic, we have these geniuses like Ramanujan in some kind of village in India, or a guy with a mobile phone could think of a better idea for an algorithm, upload it to TIG, and suddenly hundreds of thousands of dollars worth of crypto are just flowing into his account. It's the most, you can't do that with Bitcoin, right? You can't set up a Bitcoin mining operation in the middle of the Amazon if you don't have any money, right? Where are you going to get the ASICs from? But in this case, it's pure creativity.
Yeah, and that's one of the things that attracts me to DeSci in this field. I mean, of having these economic incentives at a global scale, this permissionless and anyone can come in. It's like you are crowdsourcing potentially the best intelligence in the world.
Yes, exactly. I mean, the great thing about crowdsourcing, obviously you open up a cohort of people who can get involved, but also you make them self-selecting. So this is because the difficult bit is finding these people. And if you don't have to put that work in, if they can just come to you, the people who don't come up with the ideas, they never even touch your network. You don't even get a single ping from them. So it's only the high signal stuff which comes through. And people can upload as many algorithms as they like. If they're not competitive, they just don't get used. So this is a bit like, the best kind of just percolates to the top. You don't even have to market it. I mean, the benchmarkers in our case, who are the miners, are so highly motivated to find the best algorithm. They test all of the new ones that come out, as soon as they come on their own sort of local testing, right? So it's like, I've got a better algorithm. It's like, who cares? What are you going to do? Like, run an ad for it at the Super Bowl or something like that. Like, these people are trying to find this stuff. They're so motivated to figure out whether some anonymous guy who's uploaded an algorithm has come up with something good that, it really is just all about the creativity. You don't have to do the other side of it, which it's a beautiful thing, right? Lowering the barrier to entry.
Yeah, absolutely. To pivot a little bit just into the economics of the protocol, licensing plays a big role in capturing the value from the IP generated within the ecosystem. So I know that this is probably will take a while to come to fruition. I mean, you guys, as you said, like you've been open for about 8 months, something like that. I mean, even though the idea has been in production for 10 years, right? So it would make sense that there hasn't been a ton of demand yet. But I was wondering if you have seen some interest in this area and how you're thinking about attracting demand from licensing in the future.
Yeah, so we have seen interest in this area. So I can't really names right now, but maybe I could just sort of sketch out one example. So there's a guy who's a music producer, and he's produces music. I think a lot of the stuff he does is for video games and films, but he has worked for some quite big bands as well. And one of the things, I guess this guy's also technical as well as a musician, but one of the things he's working with Sony and NVIDIA to try and find a way to isolate individual sources on music. So music tracks sometimes they're recorded multi-tracks, sometimes not, but even if they are, they usually have several instruments on each track. And often you only have access to the sort of the single kind of mashed up with everything combined. But if they can separate the different instruments, they can do all sorts of things. They can do remixes, which are much more effective. They can do things like spatial audio. So if you're walking through a room and let's just imagine the band was in the room with you, certain instruments will get louder as if you turned your head or moved towards them. So there's all of these things which that ability would unlock, and it's purely like a computational thing. And they're quite far from being able to do it at the moment. They know that it's possible. And so this guy has suggested to us, and we're sort of matching up with a guy, another one of our advisors, who's a sort of professor at Oxford University in low-rank matrix multiplication. Anyway, so this is the way that they do it, and they combine it with sort of neural networks, essentially, and constrain them in certain ways, so that you can get out these sources. So these guys, I mean, they want us to take on this challenge, and we will, because I think it's a very interesting one. And it's not about just music. There's all sorts of things you want to de-mix, in fact, in sort of science and technology. So it would have other value as well. And the idea is, of course, that they will sort of, take a license. If anybody discovers anything, they want to have a license already. So the price of the license might go up if they just, if they get it only after it's discovered. That's the sort of nature of this thing. So again, these are problems with very high industrial value, which, lots of people have been trying to solve and aren't sort of going very quickly. And the fact that you can sort of crowdsource this, and if somebody figures it out, they can get a reward which is somewhat commensurate with the value of what they created. That, in fact, doesn't exist at the moment. So this is, it's there were kind of various parties who are sort of interested on this level, but it's at the moment, as you say, it is for stuff which we hope and expect will be created in the future. The challenges that we have in at the moment are, being sort of good as sort of, test challenges, and they are up to the state of the art now, but they're not yet beyond the state of the art. So they're not sort of, we haven't sold any licenses for them yet. But as you say, it's sort of still early days. And, this stuff does take a while. And but I'm happy to say it seems to be sort of so far so good.
That's so interesting. I was not expecting you to say music as someone in the industry who wants to have one of these algorithms, but it makes so much sense to me. Like, before I got into crypto, I was a professional musician, and I kind of found my way into crypto through that. And this is a huge issue and something that can be very profitable. If you create software that can do this, every studio is going to want that. Plus, every kid in their bedroom who's remixing tracks is also going to want to get their hands on this software. So this is a really big problem within the music industry, and a problem that could kick off entire new waves of innovation for the type of sampling you can do.
Absolutely. So I was blown away when this guy said about this source isolation problem, because I used to work on these things called inverse problems, which basically sensing problems when I was, and this was sort of trying to sense the fractal dimension of a surface by looking at the way that it bounces light. But interesting that the archetypal example, like the first sort of inverse problem that everybody refers to was in music. And I think it was contrived, this particular one. This very famous probability theorist from Poland called Mark Katz considered the question of, if you had a drum that had a sort of uneven shape, and obviously most drums are circular, but you could have one that was like hexagon or some other uneven shape. Could you hit that drum and just listen to it and know what shape it was? And this was the question he asked himself in this famous paper where he wrote it out. And basically, to a large extent, you can. There are some shapes that you can intentionally craft, which are very weird, which have the same sound exactly as another shape which is different. You have to do that intentionally. And it's very hard to figure out what these two degenerate cases, as they're called, are. But in general, with any kind of just somebody made a weird shaped drum, you could tell what shape it was just by listening to it. How amazing is that? And he figured all of this out. And so this guy was like, it's like come full circle, basically. Mm-hmm. This is the problem that started this entire field, and it just happened to be in music. And now we have a real music problem. Which is, again, a classic example of an inverse problem. It's very easy to sort of mix things up, go in one direction, but to back it out and invert it and say, where did this come from, is much harder. And that's a great computational challenge, which is unsolved to this day. And as you say, it would blow people's minds to be able to take those individual instruments out and change the levels. And normally you can only do that in a recording studio, right? I mean, that's the thing. And so it's about lowering the barrier to entry.
Yeah, I mean, I have firsthand experience with that, taking a track and trying to pull part of the sample out. But there's other sounds that are coming in and out, even if it is recorded on single tracks. Like, you're getting room noise, right? Like, you're getting different, like, tiny cymbals going into the guitar track. So yeah, I think anyone who's a musician and watching this will immediately understand why that's important.
Oh, I'm glad. Yeah, it's great. Yeah, no, it's absolutely fascinating. Again, somebody said, do you want to have a call with this music producer? I was like, oh, this is not going to go anywhere, is it? And it's just like, blimey heck, this is the most interesting thing. So it's amazing.
People who are really into production, really deep into engineering, they love this stuff. I mean, these are huge problems for them. So
this is what I realized. This guy was a real engineer, as well as a musician. So he was, highly technically proficient as well. So yeah, it's great. I'll tell you what his name is offline, but I won't say it on.
So this is a bit of a tangent, but we spoke a while ago, I think this a couple months ago, and something that you said really stuck with me. This was shortly after DeepSeek launched the R1 model, and you had said that the important question that people should ask themselves is why they decided to launch open source. And when you fast forward to today, it's pretty abundantly clear that tensions between the US and China have only grown. So I'm curious to get your thoughts on, first, given the present US-China situation, what do you believe are some plausible explanations for why DeepSeek launched open source? And then second, your perspective on AI's role within the current geopolitical environment that we're in.
Sure. Yeah, so the first thing to say is that sort of DeepSeek's open sourcing of model and their method was really sort of close to the strict definition of open source. So they did release the trained model open weights, so anybody can run it locally and so on. But they also released a detailed write-up of precisely how they achieved this. And the interesting thing about it was they achieved it using methods which have never been seen before. They invented something genuinely new, and even the kind of top American AI researchers confirm this. There's no denying it because it's in the paper. So given that this thing was a very powerful breakthrough and really kind of the biggest breakthrough since invention of the kind of introduction of transformer architecture in 2017. So again, it's sort of commensurate, roughly 100x improvement. So absolutely transformational, game-changing stuff. There's a question as to why they wouldn't really just want to keep that advantage to themselves, right? I mean, even if you're just a commercial company, you can generate these incredibly expensive models. We all know how expensive they are to train, for 5% of the cost. It's a 50%, 7x. So some guy's spending $1 billion, you can spend 50 million, and you can get the same effect. And also, very interestingly, it was something that really negates the advantage, the types of GPUs people in the West had access to relative to the ones that the people in China had access to. And the reason why they were worse in China is because they had less so-called memory bandwidth. So the movement of the kind of information between sort of data between chips and the memory was a lot slower. And this was done intentionally, and it just meant that this didn't matter as much. I mean, and it seems like that's the reason why they started thinking in this direction. But it not only works on these worse GPUs, it makes things much more efficient on the better GPUs as well. So it is a kind of interesting question as to why they would sort of open source this. I think a lot of people kind of lazily assume, and it might even be true, that all kind of companies, especially ones of great significance in China, are kind of closely sort of watched and monitored by the Communist Party. And and DeepSeek was it was on everybody's radar before that. People kind of in the know. They came out of a hedge fund and they bought an enormous number of GPUs. I think before the advanced GPUs sort of export to China had been banned, and they were known to have some very, very smart people. So they were known about. So it wasn't sort of a great mystery. And so you might think, even as a commercial proposition, it seems strange to open source it, let alone if the sort of Communist Party had anything to say, why give your best secrets away to your competition? So I would say there's really kind of two scenarios. I mean, one, you might assume that there might be a mixture between these things, but one extreme scenario is they're just like a normal company and no government people tell them what to do, right? In this case, you could kind of rationalize it by, we want to bring ourselves fame. Everybody will know we're the top people. We get lots of investment. Maybe the smartest people in the world want to come and work for us. So this is a pretty big payoff. That's kind of monetizable, even if we open source it. Another thing some people, which I think is plausible, is because they were sort of spun out of a hedge fund. Maybe they just put a big short on NVIDIA, right? And it's a pretty good way to make money because NVIDIA crashed. After they released it, maybe we're not going to need all these powerful GPUs anymore because it's so much more efficient to train with this new method. And again, sort of monetization. But to me, again, that probably only works once, right? And especially the fame thing, right? Like now they're famous. It's not that they're going to get extra famous. Like everybody knows they're probably at the cutting edge now. And so what about the next thing that they discover? Are they going to be as motivated? There's clearly, fewer reasons to open source that, which is worrying. And if we think of the other scenario where they are kind of effectively sort of asking permission from some of the local official for whatever they do, it gets even more perplexing, I would say, because I doubt that the Communist Party are very interested in putting shorts on NVIDIA. Maybe they are, but I think they probably have bigger fish to fry or certain higher priorities. They don't really want DeepSeek to become famous. What do they care? I mean, maybe they'd rather they just sort of quietly do their job and kind of feed them the information that they need. So in that case, it's really hard to tell. And this is the thing to me which makes it concerning, and it makes it concerning that it's not more discussed, because if it's inexplicable, is this not a good thing to be debating around? And second, I hardly ever see anybody really discuss it. It's not a question. People are always talking about, like, is Sam Altman going to buy a new Koenigsegg or something like that? They're not saying why did DeepSeek open source their model. But it makes you think that maybe they didn't release all of it. Maybe they had something even bigger than that, and they just dripped something out to see what effect it would have, to sort of flex against the others, to say we've got, China's got better technology in some sense, or better people, or is more innovative than America. Maybe they sort of see what effect it has on the economy. And we are in a very dangerous situation at the moment, because the economy, by a lot of people's measure, is sort of overbought, sort of overheated. But it was all for a very specific reason, right? It was because of a particular product, which is very popular, very profitable, which are these AI models. But it's a product for which, almost uniquely, you cannot block the import of, and you cannot put tariffs on. If you make this thing available for free, and again, because it's all about algorithmic methods, it's zero marginal cost. You can produce as many of these things as you want. Once you've got one of them, you can just copy them. You can deploy this better method to all your GPUs, and you flood the market with something which is unblockable and unstoppable. And that's the thing that the economy is depending upon at the moment for its elevated valuation. So that's a pretty big sort of move to be able to play, right? And it seems like maybe they played it, maybe they didn't. Maybe they were just putting out some feelers to see what would happen if they did play the real move. Who knows? I'm not a geopolitical analyst here, but I'm just surprised about how sort of, kind of people kind of blase it. It's like, oh, they just open sourced it. I mean, OpenAI doesn't open source things. Right. So why the hell should China, the most closed country, in the entire world, as everybody says, and the land of the free, America, with OpenAI, keeps everything as a trade secret. So the sort of the curiousness of this is a little bit worrying. But to us, again, I mean, in a sense, it was quite helpful because we talk about algorithms. This was an algorithmic breakthrough, the DeepSeek kind of, revelation, what happened. And yet, if people post about hardware on Twitter, it's like hardware porn, right? Everybody loves a new piece of hardware. Nobody's interested in algorithms. I guess it's less tangible, but it's just far, far more important. So, I think those are the kind of scenarios in my head, but it still doesn't sit right with me. And that to me means that there's sort of, even more urgency and hopefully a wake up call for the world about how powerful algorithms are and about the fact that if we do have a hardware advantage, I say what we should do is use a big chunk of that hardware to mine for algorithms. Some of it you use to train new models to get money in to sell as a product, but a large chunk of it should be used to find better algorithmic methods so that you can stay on the cutting edge. Because if you're just trying to sell everything, just make as big a model as you can, you'll fall behind on the algorithmic front. And also, we need to keep these things open as well. So open is to an extent that, we have an advantage. It is the openness, right? Openness will win over closeness because people can collaborate. If, people in America don't use that advantage, you've got nothing. What do you have other than openness? Nothing. You don't have more people. The people obviously aren't necessarily smarter. Whatever the DeepSeek people did this, they've got probably multiples of the industrial capacity. Sort of what we have is a sort of a culture of openness. And I really hope that we can leverage that to our advantage. And what that means very specifically is not starting big companies saying you're going to be open and then closing them all. That's un-American, man. That is I'm not an American myself, but you know where I'm coming from here. So this is what we're all about.
Yeah, makes sense. What are some of the things within the innovation game that are currently happening that you're the most excited for? Things that have been insightful or inspiring so far?
So, I mean, there has been a lot of stuff that the reaction from top people in the algorithmic field, when the ones that we have managed to have a kind of conversation with, has been, stupendously positive. And, that's kind of exciting to kind of get tapped into those networks that are, kind of at the moment, it's sort of all about mostly about human capital and, making progress in that area has been very, very good. I think also, I mean, this issue of automated algorithm development, we're building an automated algorithm developer with partners as well, whose names we won't divulge at the moment, but let's just say they're people who are many times larger than us as a company. And we've managed to sort of put a bit of a consortium together whereby we're going to build this algorithm developer. And, we have a very nice tangible metric as well. Like, have we done well? Has this project succeeded? When you run the algorithm developer and it's earning more money from TIG than it costs to put in to run it, that means it's takeoff time, right? It can scale itself up. So, normally it's like you find a better algorithm. How much is that worth? I don't know. I mean, maybe we'll know in 10 years or something. And but in this case, we have a good market signal to get some sort of feedback as to whether it's, how close we are to our goal. So that's something I'm quite excited about, the fact that we managed to kind of pull in so many interested people on that project. I'd say, what else? We're putting in new challenges. So the next one we're going to put in is a challenge which will incentivize people to build a better optimizers, so-called non-convex optimization, which is what they do to train neural networks, essentially. So this challenge has really been a kind of next level in terms of how long it took to develop. It's more complex than the first 4 that we put in. And lots of people have been working on it for many months. And it's basically ready now, which is fantastic. So now we're just going to think about maybe the timing of deploying it, kind of spreading out our announcements a little bit. But again, if somebody finds a better optimizer, which is, again, one of those root node problems, this is specifically for AI, they can put it into the innovation game and it is open forever. Plus the fact they get the reward from having put it in there. They'll get the tokens. We feel like we've made something like a strict improvement on open source. It's open source. It's open to everybody forever. plus you can capture value from it. And it's not that academics don't like money. It's like usually they won't compromise their principles often. And open source people of being open. They like money, but not on those terms. But as far as we can tell, these are terms which are agreeable to them. If the terms are agreeable, they can use that money for more research and to hire more for people for their group. So we've got a lot of positive feedback from that. And it's just it has been a hard slog for the last 7 months or so because there have been things to kind of refine and adjust and so on. But we're kind of at the scaling stage now. So that's a better place to be.
That's super exciting. Yeah, thank you so much for coming on. I feel like whenever we talk, I learn so much. I just love sitting back and listening. So before we wrap up, where can people find you? Where can people follow along to TIG? And then if people are interested in either being a benchmarker or innovator or getting involved in the project some way, what's the best way for them to go about that?
Yeah, so the sort of central hub for everything is our website, tig.foundation, so just tig.foundation. Please do follow me on Twitter. It's dr_John Fletcher, which is all one word, and also TIG Foundation on Twitter as well. And I'd encourage people, normally I would say you want to find out more. I used to say sort of read the white paper. The white paper is a little bit heavy going, so for technical people, I would encourage that. But I recently published a sort of so-called kind of vision piece for the innovation game. So I think I would recommend that as the first sort of point of contact. You just want to sort of hear from front to back what it's all about. And I can share the link for that with you. Maybe you can put it in the description or something like that. But if not, you can find a link to it on the TIG website. And so benchmarkers and innovators, if you go to the TIG website, that will lead you to the Discord where you can debate with all the other benchmarkers and innovators as well. There's also a kind of just a contact address, email address that you could reach out to us, which can also be found on the website. So we're very happy to hear about inquiries and people who want to get involved.
Awesome. All right. Thanks again, John.
Pleasure. Thanks, Chris.